Hi everyone, welcome to your channel Impulse Tech. I am Yogesh. So today I come up with a new project and that project is suggested by you guys. So few days back I have run one poll on the community where I ask you that which project should I create next. So you have voted for the project which should be based on the Arduino IoT cloud. So now I have created the interesting project that is IoT-based Smart Garden. So let's see what is the functionality of this project. So this project make your garden smart. Now how to make your garden smart? So here you can able to monitor the temperature in your garden. You can able to monitor the soil moisture in your garden. You can able to monitor the light intensity in your garden. That means whether there is a proper sunlight or not in your garden, that you can monitor. Also you will get notified whenever there is a rainfall. Now let's see what you will learn in this project. So you will learn to interface all these sensors with ESP32 and you will learn about how to configure the Arduino IoT cloud platform. Also, you will learn about how to write the code inside the Arduino IoT cloud's web editor. So without wasting time, let's get started and make our garden smart. So now we will see how to design the circuit for this project. So I have already designed and I have already connected everything together. You can see here. Now we will see how to connect each and every component to the ESP32 step by step. So as you can see on the screen, I have added all the components that we need to build this project. So I have added here soil moisture sensor, rain sensor, DHT11 sensor, light sensor module. Also I have added the relay to control the pump. Also here you can see I have the 12 volt pump here and the 230 volt supply. Okay, so now we will connect each and every component step by step. Okay, so first of all, what we will do, we will connect all the VCC pins of each and every sensors together and connect it to the V-in pin of the ESP32. Here you can see this is the VCC pin of soil moisture sensor. Let's connect it to the VCC pin of rain sensor. Same way we need to connect the VCC to the VCC of DHT11. Just make a common connection between all the VCCs. Here you can see. Yes, so I did the common connection as you can see on the screen. Okay. Now also there is a VCC here in the relay as well. So let's connect the VCC of relay. Okay. So let's connect the VCC of relay to the common VCC that we have created like this. Now we need to connect the single wire from this to the V-in pin of the ESP32. Here you can see the V-in pin. So let's do the same thing for ground. So let's make a common ground connection between all the components. So just take the ground from here and let's connect it to the ground of rain sensor. Let's take the another wire. So now we have made the common connection of ground between all the components and now we will connect this common ground wire to the ground of ESP32. So the common connection between the ground of all the components is made with ESP32. Okay, so now we need to connect the individual analog input and the digital input with the ESP32. Okay, so I will connect the soil moisture sensors analog output to the analog pin 34 of the ESP32. So I will connect the rain sensors analog output to the pin number 32 of the ESP32 board. So now I will connect the data pin of DHT11 to the digital pin 13 of the ESP32. So now we will connect the analog output of light sensor module to the analog pin 35 of ESP32. So we have connected these four sensors. Now we need to connect the relay board. So relay board has the input pin 1. This is the digital input. So we need to connect this to the digital pin of the ESP32. So here I am using the D4 of the ESP32. So I'll just connect it. So let's connect the input 1 to the D4 pin of the ESP32. Okay. So now we have made the connection between all the components. So now we will see how we are going to connect the pump to the ESP32. Okay, so we need 12 volt SMPS. So let's search for 12 volt SMPS here in the library and go to the user contributed, and here I've got the AC-DC power supply. So I will take this AC-DC power supply and I will add it here. So here is the AC-DC power supply. Let's add it here. So now I have added this 12 volt AC-DC power supply. So why we need this 12 volt AC-DC power supply? Because we have this 12 volt water pump. I'm just trying to explain you this circuit diagram as detailed as possible, because you should not make any error while connecting your pump to the relay board. Okay, so I have got this AC-DC supply. I have got this 230 volt power supply also. Okay, so what we will do now, we will make a connection between this line and neutral. I'll just connect it here. So this is the connection between your socket and the 12 volt DC adapter. Now we will connect the wires from adapter, that is DC adapter, directly to the pump like this. Okay guys, so here I have added one more component, which is AC voltage source. That means, so this is the socket where we are going to connect the DC adapter, and this DC adapter is connected to the 12 volt water pump. Okay, so now what I will do, let's see here. So first of all, what we will do, we will directly connect the line wire from the AC voltage source to the common point. So let's take one wire from the line, from the socket, and connect it to the pin 3 of the relay. Here you can see. And the neutral should be connected to the neutral directly. This is the AC voltage source. You can see the name here. So we have this AC voltage source. This is the power that we get in our home, which is 230 volt supply here in India. And we have a socket which also has the 230 volt supply. Now in 3-pin socket we can connect the DC adapter. So this DC adapter is directly connected to the socket, and then DC adapter gives us the 12 volt output, and this 12 volt output is directly connected to the 12 volt water pump. Now here socket connection. So now here the main catch is the socket connection. Okay, so in the common point of the relay I have given the line connection directly. Here you can see. And now the line from the socket I have taken and connected it to the pin number 3 of the relay. So what does it mean? So whenever we will turn on and off the relay, the connection between line closes with the help of relay, and your pump will turn on automatically. And the neutral connection of the socket is directly given to the neutral point of the voltage source. This is very simple. Maybe this looks quite complex to you, but just follow the step-by-step instructions and then you can easily figure out how to connect the pump to the relay board. So here I have just tried to explain you each and everything in the circuit diagram so that you don't get confused. So I hope you understood this circuit diagram. Even if you don't understood this circuit diagram, just let me know inside the comment section what part of the circuit diagram that you don't understand. Okay, so now we will jump onto the most important part of this project, that is how to configure the Arduino IoT Cloud platform. Okay, so now just search for Arduino IoT Cloud. Click on enter. So just click on this first link. So Arduino just modified, or you can say just changed their user interface of the cloud platform. So they have integrated everything like code editor and other stuff which they are providing in Arduino Cloud. They have integrated in one place. Now you will see there are changes in Arduino IoT Cloud platform. Also, if you watch my previous videos, there you will see a different kind of platform. But now they have integrated everything into a single platform. So let's click on get started for free. This is the new Arduino IoT Cloud platform. They have modified entire thing and they have integrated everything together. Okay, so here you will see devices, things. Here you will see your account, home, sketches, devices, things, dashboard, triggers, resources, courses, IoT templates. That means they have integrated everything together at one place. So this is the new updated Arduino IoT Cloud platform. So in order to configure the Arduino IoT Cloud platform, we need to do few things. And what are those things? So first, we need to create a thing. Second, we need to add a device. We also need to create the dashboard for the device that we have created. And also, we need to write the code inside the Arduino's web editor platform. So these many things we need to configure. So on the left, you will see things. Let's click on that thing. Let's click on create thing. In order to create a thing, we need to add these three things. One, we need to add cloud variables. We need to add a device. we need to add the network credentials. So first of all, I'll just rename this thing and I will give the name. Now we will add the cloud variables. Okay, so first of all, I'll add soil moisture sensor. So I'll make it SM sensor. And I'll select the variable type as the basic, which is integer. And here you don't have to select anything. That variable permission, just keep it as it is, like read, write and on change. Okay, so I'll just click on add variable. Okay, so we have added one variable which is for SM sensor. Now let's add one more variable which is for light sensor. So I'll add here light sensor or light intensity, we can write. Select the variable type as the integer number and directly click on add variable. Okay, so add one more variable which is for temperature. So I'll write here temperature. I'll select the variable type as energy, and here inside the energy we'll see some that do we get some temperature kind of thing. Yes, we got the temperature. Okay, so now I will just click on add variable. Let's add one more variable which is for rain sensor. So I will add rain sensing, and here I'll select, sorry, I have given the space. So here I'll select the basic variable type as the integer number and just click on add variable. Okay, and the last variable that I'm going to add is relay in order to control the pump. So I will type relay and select the variable type as boolean, because relay is basically a digital device. That means we wanted to turn it on or off by giving the 0 or 1 from the ESP32. So that's why I have selected the variable as the boolean type. Click on add variable. Okay guys, so we have added all the variables that we need. Here you can see I am not able to add the one more variable because I have not upgraded to the paid version of the Arduino IoT Cloud. So now we will add a device to the Arduino IoT Cloud. So let's click on this select device and we will add a new device. So I'll click on set up a new device. I'll click on third party device because the board that so here we need to select the third party device. The device that we are using here is ESP32 and which is not the Arduino's device. So that's why we need to click on the third party device. Let's click on third party. So here in the third party we have to select ESP32, and ESP32 also has different models. So here we have to select ESP32 dev board. Let's look for that. Here you can see guys, ESP32 dev module. Let's click on that and now click on continue and give the name to your device Smart Garden ESP32. So I'll write here Smart Garden ESP32 so that I should know which device I have used for which purpose. I'll click on next now. Okay, so this is the very important part. You have to download this secret key and also you can copy this secret key as well. Now click on continue. Okay, so now we have successfully created the device. Okay, let's click on done. So now we will add the Wi-Fi credentials. So I'll just click on configure and give the name of the Wi-Fi. So I will use the Wi-Fi which I'm using here in my mobile phone as well and in the laptop as well. So you can use any Wi-Fi network which you are using. Yes, so I have added the password and also the secret key. Now we need to write this sketch, right? So this is the Arduino IoT Cloud's web editor. Okay, so we need to write this sketch. So before that, what we will do, we will just create the dashboard. Now let's create one more dashboard for our Smart Garden project. So I will rename. So on the left, you can see, if you click on add, you will see all the widgets here. So now you can add all these widgets apart from this. This is, in order to add this widget, you need to upgrade it. But you can add all these widgets. So I need to show few data. So for that, I will mainly add the gauge and the one widget which is of like I need to add is switch. Just take the switch here. You just have to click on the switch. So we have added the switch in order to control the pump. Just rename it as a pump and link a variable. So which variable we wanted to link, and we know that which variable is a boolean variable. This is the variable that we need to connect. So make sure that you have selected the right thing. So here Smart Garden using the Arduino IoT cloud and the relay I wanted to add, and link variable. Show thing name on the widget, you can just write it here as well. So your thing name would be here Smart Garden. Okay, now you will get the on off label here. If you don't write it, your on off label will not be there. I just want the on off label, so I have clicked on that. Let's click on done. So we have successfully added one widget to control the pump. Let's add another widget, which is gauge. So here is the gauge. Let's click on that and just rename it as a moisture level and link a variable SM sensor and click on link variable. So I will show the thing name on the widget, and here the minimum value I will get is 0 and the maximum I will get is around 4095. So here we are using the ESP32. So ESP32 has the 12-bit analog resolution pin. So that's why we will get the maximum value of 4095. I'll click on done. Let's add one more gauge for light intensity. And here link a variable light intensity. Click on link variable. Here also I will get the maximum value of 4095 and click on done. One more widget I will add, which is one more widget for temperature. Let's add the gauge and right here temperature, link a variable temperature. Here keep it as 0 to 100 only. Okay, click on done. So we need to add one more, which is for rain sensing. Right here rain sensing. So here I will write the maximum value of 4095, which I will get. So guys, we have added all the widgets and all the variables in order to show the data. We will jump on to the most important part of this project, that is writing the Arduino Sketch. So let's click on the things that we have created, which is Arduino Smart Garden monitoring system. Okay, so here you can see the sketch option. So just click on the sketch, and now let's click on open full editor. Now it will open the Arduino's web editor. Now like Arduino has this cool feature that it has integrated the web editor. That means you don't even need to download the Arduino app in order to program the ESP32 board. Okay, so guys, I have already written down the code. Now I will walk you through the line by line of the code, and I will tell you what are the things that you need to change inside this code. Okay, so here if you see, I have included one library which is responsible for DST sensor. So in order to include the library, you just have to write this code that #include dst.h. So it will call this library. So I have connected the DST sensor to the pin number 13, which I have already explained. And here I am using the DST type is the DST11 sensor. There are two types of DST sensor. One is DST22 and DST11. Let me tell you one thing, that we have defined few cloud variables already inside the Arduino's platform. Now here you can see those variables which you have defined while creating a thing. Okay, if you go back to your thing once again, here in the setup, you will see what are the different cloud variables that you have created: light intensity, rain sensing, relay, SM sensor, and temperature. So all these variables are already declared here inside the code as well. So we don't even need to declare it once again. But before that, we need to tell the Arduino that we have used these pins. For example, for soil moisture sensor, we have used the analog pin 34. For light sensor, we have used the analog pin 35. And for relay, so here I have given the relay variable name relay_1. So make sure that you don't use the same name that you have used for the cloud variables. So here you can see whatever the variable name I have given is different from the variable which I have defined while creating the thing. Okay, so relay_1 is connected to the digital pin 4, and the rain sensor is connected to the analog pin 32 of the ESP32 board. So now we have defined all the pins of the ESP32 that we are using. Okay, so here the relay pin is basically the output pin that we are using. So that's why inside the void setup, you can see guys, I have defined pin mode relay underscore as an output pin. And here you will see this line that serial.begin is basically to turn on the serial monitor in order to read the data onto the serial monitor. So this is already there. I have not written anything. So I am just telling you what are the things that I have written. So I have written all these things like hash include dst.h, define dst pin 13. So these things I have written. I haven't written anything. So this is like by default code which you will get once you create a thing. Let's come inside the void loop. So inside the void loop, what I'm trying to do, I'm trying to read the analog data. For example, if I wanted to read the light intensity, then I need to use the command, or you can say the function called analog read, in order to read the analog data. Okay, now you know that we have defined cloud variables. So light intensity is the cloud variable. So I need to store the analog data I'm getting from the pin number 35. So what I've done here inside the void loop, I have used the same variable. I have used it here, light intensity is equal to analog read, and used the pin number here. So analog read is the function where we can use that function to read the analog data. And now we are storing it, that analog data, to the cloud variable light underscore intensity. So the same thing I have done for SM sensor, and I'm storing the soil moisture sensors data using the same command called analog read. So done the same thing for rain sensor as well. So here using this command, like float temp is equal to dst.read temperature opening closing bracket. So here this command has the temperature data. So I'm storing that temperature data to our cloud variable temperature. Now here in Arduino IoT cloud, with the free plan, I am only able to create the 5 variables. So that's why I'm only reading the temperature data, not the humidity data. Now this is all for monitoring the data onto the platform. Now we need to control the things from the platform. Here you can see we have defined one function called on relay change. It means whenever you are clicking on the dashboard's button widget, turning it on and off, then what would you like to do? Then what I've done, that if relay, which is cloud variable, that means if you are turning on and off that toggle button, then if it turns on, then what I'm doing, I'm just turning on the relay 1 high. If it is turned off, then I'm making it low. That means it will turn off. This is the code you need to write in order to control the relay. So this is very important line of code that you need to write. So guys, this is the very simplest coding that I have written down inside the Arduino IoT web editor. So I hope you understand this code. Even if you don't understand this code, just do let me know inside the comment section. Just pay attention, this is very important part. In order to upload the code from Arduino's web editor to your ESP32 board, you need to have an Arduino agent installed. I'm telling you once again, you need to have an Arduino agent installed in your laptop, then only you can able to upload the code inside the ESP32 board. Now guys, here you can see I have selected this board, which is ESP32 DevKit V1. Now you can able to upload this code only when there is an Arduino agent installed. There is no error in the code, so I have already uploaded this code into my ESP32 board. Now I will show you the output on the screen. So guys, you can see the project in action now. So you can read all the data on the dashboard. Here you can see the moisture level, the light intensity, and the temperature. Also you can see the rain sensor data. So if I remove this sensor is in the water. Now you can see this is the white container which has the water. So when I remove the soil moisture sensor out of the water, the reading is increasing. Once I insert it, the reading will decrease. Now you can see on the screen. Also you will see the rain sensor data if I add some amount of water on it. So I'm adding the water droplet on it, and you can see the rain sensor data now. It is increasing. So here you can see. Now it's decreased. So if I add too much of water, then data will decrease. So this is for rain sensing. And also you can see you will get the temperature and the light intensity data as well. So if I just turned off this light, then you will see the light intensity data as well. You can see now the light intensity data that increased. If I turn on the light, then light intensity decreased. That means we are successfully able to monitor the light intensity data as well. Just that the data is reversed. We can change this data into the coding that whenever the light intensity is too much, the data is also increased. Now the data is inversely proportional to the light intensity. That means the light intensity is more, the value of the data is less. Okay, now we can see the moisture level, we can see the temperature as well using the temperature and humidity sensor, which is DST11. And now we will just turn on and off our pump. So here guys, you can see that I have used this relay, but this relay is not working. Then I have used this 4-channel relay which has the optocoupler. So I will suggest you to use this optocoupler. Do not use this kind of relays. So this relay will work very smoothly. So now I have used one of the relay, and then I have used one smart plug. So this smart plug is directly connected to the power which I am having with me. Here you can see this smart plug is connected here, and then I have connected to the relay 1. Now that relay is connected to the ESP32. Here you can see guys. Okay, now this is the SMPS, this is the 12 volt SMPS, and this is the pump which I am having. So I have connected this SMPS to the pump using this connector. So now we need to connect this SMPS to the plug, and then we will try to turn on and off the relay using the Arduino Cloud's on off button. So let me connect it here. So guys, let's see. I'm going to turn on the pump now. Let's see the pump is in action. So let me just click on the pump. So you can see the pump is started and the water is started. Here you can see. Just closely monitor it. So I have started it. Let me just close it. It's too much now. The water is too much there. So you can see. So guys, we can build this entire project on a single PCB. So we can build our own smart garden monitoring and controlling system. So this is my prototype model. So that's how I have created everything together. I hope you found this project useful for you. Then do subscribe the channel, like the video. Thanks for watching. See you in the next video.